Okay, let us discuss the next problem. So this is problem number 1.235. So this is a, let me write here. So this is problem number 1.235. So what this problem says, a force F, so I have a force F, this is given AI plus BJ. So this is the force, is applied to a point whose radius vector to the origin of coordinate is this. So radius vector is given AI plus BJ. So this force is applied, so let me write a coordinate system. I have origin here. Now the force is applied from here. So this is my force, this is my radius vector. So this force is applied. I can have, basically this force is not parallel to x-axis. This is a something different. So you can make a something general. If you want, you can draw this force something like this. Are you getting or not? So this force is not necessarily parallel to the x-axis. So I can draw this one. So this force is not necessarily parallel to the x-axis. Now this is asking where A, B and capital A and capital B are known. I, J are unit vectors. So this is given, this is given, this is given, and this is also given. X, Y are the axes. Find the moment N and lever or L of this force related to point O. So what the question is asking, what is the moment of moment? So we have to find moment of this force about O. So this is fairly easy problem. Moment about O. So everybody knows. So moment is what? Moment is R cross F. So if you use moment is R cross F, now R is what? R is AI plus BJ. This cross R cross F, a small AI plus capital AI plus capital BJ. Now if you take cross product, I becomes 0, I cross J, so A into B, and I cross J is what? So if you have I in this direction, J in this direction, so I cross J, it will come in this direction, that is basically K. Are you getting it out? So if you have a right-handed system, I cross J is equals to K. So if you go from this side to this side, so let us see, if you go from this side to this side, a screw will come outside, and that is basically K direction. So I cross J is K. Now B is J cross I, that is minus K. So this will be, let me write here A, B, and this is nothing but minus K. So I have already given the sign. Now J cross J is 0. So this will be finally AB minus AB into K. So this is the moment vector. Are you getting or not? So magnitude of moment vector will be simply this, the magnitude of moment vector, you know. So simply the magnitude of moment will be, this is simply AB minus AB. So if you take the mod of this function, you will get AB minus AB. So now this is the first part. You have to also find what is the lever arm L of the force relative to point O. So this is the magnitude. What is the distance lever arm? So how will you find lever arm? That is, what is the lever arm? So you see, let us say, if you have a lever arm, this is the perpendicular distance of this force from origin. So we want to find what is the perpendicular distance this force has from origin. So you see, the magnitude of moment is this. So magnitude of moment is this. This force, magnitude of moment, is equals to magnitude of force into perpendicular distance. Are you getting or not? So this will give you lever arm. So what is the magnitude of force? Magnitude of force is, you see here, so force is given, this is given, you see here, so force is what? Capital AI plus capital BJ. So I can write here. So force is nothing but capital AI plus capital BJ. So you can find what is the magnitude of force. So magnitude of force will be simply A square plus b square under root. Are you getting or not? If you're not getting, let me ask. Oh, how can you ask? Maybe I will not in the class. Okay, so let us write this one and then we will discuss. Now you see, I said moment is given by, so this is the magnitude of moment. I can also write for moment that is a force into distance. I have to find what is the perpendicular distance, this L. So I know the moment, this is the value of moment, this is the value, I know this is the magnitude value of force, so I can find lever arm. So AB minus AB, this is equals to magnitude of force is A square plus B square into lever arm, that is L. So from here I can write lever arm is equals to AB minus AB divided over A square plus B square. Are you getting or not? So what is L? L is basically lever arm, that is the perpendicular distance from origin to the force. So this is what? So let me write, this is perpendicular distance from origin to force F. From origin to force F. So this is the perpendicular distance, origin to force F. And that is also called lever arm. Are you getting or not? So what we have learned? We have learned using the vector method, how can I find the moment, that is R cross F. How can I find the magnitude of moment, that is R cross F mod. And third part we have learned, what is the lever arm. So we say general lever arm is defined as distance from this distance from origin. In this case this lever arm is asked with respect to origin. So in this case lever arm will be the distance, perpendicular distance from origin to the force. So you see I can show this lever arm here. So if you extend this force, so let us say this goes something like this. So this is my extension of this force. So this means if I drop a perpendicular from here, so this will be my lever arm. Are you getting or not? So this is my lever arm. Everybody getting? So this is my lever arm, and that's the value we have calculated. So what is the perpendicular distance from origin to the force direction? So this is my lever arm. So we have done this problem. This is a really easy problem, one of the easiest problem we have ever done. We'll go for the next problem.